All right, this one's interesting in that usually when we talk about tires, it's the tires stopping us and not making us go, but they do make you go, and I think we know that. So if we're going to go to the right, we have some force of friction. They're going to call this static friction, even though it's rolling. It gets a little confusing when you do that. So you got to just kind of trust me when I say it's the static friction. It is rolling, but the piece of the tire stays the same on the concrete, so that's why it's static. So really, all we're doing is, oh, one other thing, the coefficient of friction, static for tires is 1.0, so it's a really good, especially on these race cars. So that's really what we're doing here. Before we go to some of the forces, we have to convert 60 miles in 1 hour. So let's get rid of miles. 1 mile is 1609 meters. And then this is one you probably should start to get to know. 1 hour is 3600 seconds. So everything's going to go 1609. What is that? What did I write there? Usually it's late when I do these. These it's early. I'm at school. 1609 meters. All right, so we have meters per second is our unit. And let me grab my calculator. 9, and then divide by 3600, and I get 286.8 meters per second. So got to get rid of miles per hour. All right, let's go to some of the forces now. In the x direction, all we have equals ma. The force that we have is force friction static equals ma. We know that force friction static is mu. What happened to my pencil? Mu force normal equals ma. Mu force normal in this case is mg, right? Because we know it's the weight equals ma. And if I'm going to solve for acceleration, I am kind of running out of space and I have all this space over here. I'm going to come back up over here. If I solve for acceleration, it's mu mg over m. M goes away. So my acceleration equals mu, which we decided was 1.0, times gravity, which is 9.8 meters per second. There's a gravity stuck in there. So my acceleration is 9.8 meters per second squared, which is crazy. I'm going to give myself a little room here. They want to know time. What is the shortest amount of time? Well, we know acceleration equals change in v over t. That turns into t equals change in v over a. My change in v is 0 to 26.8. Remember, I converted that over my 9.8 meters per second squared. And the time it would take me to do that, 26.8 divided by 9.8, is 2.7 seconds. So that one's a little crazy, knowing that a car can accelerate just like as fast as with the rate of gravity is nuts. But there you have it. Bye-bye.